All right, let's dive right into this explainer. Today, we're pulling back the curtain on a massive hidden inefficiency in modern AI. We're going to break down exactly why standard AI models struggle so much with Indian languages. And more importantly, we'll explore a breakthrough solution that completely flips the script.
First off, we really have to ask ourselves a pretty fundamental question. If artificial intelligence is basically magic right now, why does it completely run out of breath when you ask it to speak Hindi or Hinglish? You've probably noticed this yourself. You prompt a standard language model in English and it replies instantly, but ask it the exact same thing in Hindi and it suddenly slows to an absolute crawl. Well, the AI isn't lacking intelligence. Actually, it's the underlying architecture that's working against the language itself. It all boils down to what we call the token tax. You see, standard LLMs are fundamentally hardwired for English. They read English by breaking words down into very neat, efficient chunks called tokens. But for Indian languages, total nightmare. It's like trying to jam awkwardly shaped items into a tiny suitcase. You literally have to sit on it just to get the zipper closed. Because the default tokenizer wasn't built for the Devanagari script, it takes a simple Hindi word and shreds it into dozens of tiny, fragmented puzzle pieces. So you end up paying a massive computational tax in memory and speed just because the AI doesn't natively grasp the structure of the language.
Which brings us to Section 1. Meet Bharat-Tiny-LLM version 2, Edge AI for Hindi and Hinglish. To fix this architectural mismatch, the India-first AI lab uLogic built a 1.5 billion parameter model, and their secret weapon is a fascinating technique they call Brahmi Token Injection. Instead of letting the default tokenizer chop up Hindi words, they surgically injected 300 specific Devanagari subword tokens straight into the model's vocabulary. This essentially teaches the AI to read Indian languages the exact way scripts of Brahmi origin were designed to be read, as whole cohesive units, not a random jumble of bytes.
What's honestly brilliant here is the surgical precision. By simply injecting these 300 specific subwords into an existing open-source base model, like Qian 2.5, they completely bypass the foundational language barrier. They didn't reinvent the wheel, they just handed the AI the exact keys needed to unlock the Devanagari script. It is a highly targeted structural fix.
Let's move on to Section 2, massive compression and speed and the undeniable benefits of native understanding. When an AI finally reads a language natively, the ripple effects are absolutely huge. So the magic number to remember here is roughly 34%. Well, 33.8% to be exact. That is the overall token compression rate for Hindi text. To put that into perspective, formatting 1,000 characters of Hindi used to eat up about 950 tokens. With Bharat-Tiny-LLM version 2, that drops down to about 630 tokens. The AI is doing way less heavy lifting to read the exact same data, which translates directly to lower costs and massively reduced memory usage. Let's break down a real-world conversation to see this in action. If you type a simple greeting like Namaste, Aap kaise hai, a standard model burns through 15 tokens. But with Bharat-Tiny-LLM version 2, that plummets to just 7 tokens. Bam! You just saved 53% instantly. Or take a phrase like Zaranli baat hai kya karte ho. That drops from 26 tokens down to 11. That's a 58% saving. Even Hinglish phrases see major compression. We are literally watching the death of the token tax right here.
And because the model is processing significantly fewer tokens to output the exact same message, it generates text much, much faster. We jump from 50 tokens a second on the base model all the way up to 68 tokens a second. For developers, that is a clear 36% speed boost for Hindi inference. For the user, it's the difference between a bot that feels clunky and slow and one that feels instantaneous and alive.
But it's not just faster, right? It's significantly more accurate. By actually understanding the language natively, the model achieved a 52.5% loss reduction on the Hindi validation corpus. In AI speak, its perplexity dropped from 16.1 to just 6.3. Basically, perplexity measures how confused an AI is. A drop this massive means the model isn't just blindly guessing its way through Hindi anymore. It truly comprehends it with high confidence.
All right, on to Section 3, AI on the edge, unlocking true offline capability. These crazy efficiency gains allow for something truly wild in the hardware space. Thanks to that 34% token compression and some clever Apple Silicon MLX quantitation, which basically shrinks the complex math, the team squeezed this entire 1.5 billion parameter beast into just 880 megabytes. It needs less than 3.8 gigs of RAM, meaning you don't need some massive, expensive cloud server farm anymore. You have 100% offline functionality sitting right in your pocket.
You can literally run real-time, highly capable Hindi and Hinglish AI directly on an Apple Silicon Mac, an iPhone, or an iPad, completely on device. We're talking 68 tokens a second without ever pinging a cloud server, without paying a dime in API fees, and with absolute 100% data privacy. That is a game changer.
And the best part? They didn't lock this technology behind some expensive paywall. It's completely open weights under an Apache 2.0 license. So whether a developer is running a massive Linux server with high-end GPUs or just tinkering locally on a Windows machine, this model is built to support it. It gives anyone on the planet the power to build localized, native Hindi AI tools without being throttled by that English language bottleneck.
So I want to leave you with this thought. We're moving fast into an era where everyday devices are running powerful local models. As these edge devices get smarter, what does a truly localized, India-first AI ecosystem actually look like when we finally tear down these architectural language barriers? When a model understands Devanagari just as efficiently as it understands English, it opens the door to seamless, real-time AI for hundreds of millions of people who were previously sidelined by the token tax. This isn't just a neat little optimization, it's literally the foundation for the future of localized AI.